Hello, algebra students. I hope you're having a good day. The weather's getting nicer out there, and I'm feeling like it's almost time for the end of the school year. Can you believe it? Well, I hope whatever you're doing, it's good, and that a little bit of math won't hurt. Anyway, here is a little warm-up for you. I've got 4 equations here. All of these are linear equations. When you graph them, they make a line. Each one has a form, and that form has a name. It's what we talked about in our video last time we were together. So I'm just going to ask you to pause this video for a second and answer the question, what is the form of these linear equations? In other words, what is the name of the form of these linear equations? All right, go. All right, so taking a look at A, this linear equation says y equals 4. And we already know that this is already a horizontal or a vertical line because that's what those equations look like. We already know it's going to be one of those. But when y equals 4 all the time, it really doesn't matter what the value of x is. In fact, it's not even going to cross the x-axis at all. And so we know that this is a horizontal. And that is its form. It is a horizontal equation. Now, when we look at B, it's got this structure that says y equals, and then a bunch of other stuff, including the letter x. Y equals 4x plus 2 is classic slope intercept. That's what the slope intercept form looks like. And then part C, here it's a kind of a crazy one, and it's got parentheses. This is the only one that has parentheses in it, the only linear equation that does. This form is called point slope, and actually, even though it looks kind of crazy, it's my favorite. And then the last one, 4x plus 8y equals 16, is called standard form. And you got a chart in the last video that kind of helps you decide which is which. We are going to be concentrating on this one and how we can take equations that are in standard form and use a little trick to graph them, to graph the lines. All right, but before we get ahead of ourselves, let's get that notebook updated. Pause this video, write questions for your last set of notes, write a summary for the previous set of notes, and then get a page ready for today's notes. All right, here we go. Your essential question, how can you use intercepts to graph equations in standard form? The topic graphing equations in standard form is going to take a couple of days. I will make this video, and then the next assignment will have a video that I picked up from YouTube. A couple of different assignments just to give you lots of practice with graphing equations in standard form. So quick reminder, this is a sort of a recap of what we just talked about in the warm-up and also the video that we talked about last. Linear equations come in many forms, and each form is useful in its own way. You have the slope-intercept form. That's where if you know the slope of a line and the y-intercept, you can easily write the graph of that line because you just plop those numbers into those places. Now, we're going to be doing that too here in just a bit. There's also point slope form, which is my favorite because, again, if you know the slope and then you know the value of a point that's on that line, then you can make an equation of the line. The standard form is what we're going to be looking at today. This is today, and how we can be clever to graph lines in standard form. We don't talk about the intercept form. Not really. Then, of course, there's the vertical form, x equals some number, and horizontal form, y equals some number. And those were the things we talked about a couple of lessons ago. So we're going to be tackling slope, intercept, and point slope at some point. At some point. Do you get it? But today, we're going to take on a clever way of graphing standard form equations. So now that we know we're going to be talking about standard form equations, let's remind ourselves that we can use intercepts to graph equations. The x-intercept of a line is where the line crosses the x-axis. In other words, that's where y equals 0. I'm going to show you this in just a second. The y-intercept of a line is where the line crosses the y-axis, and this is going to be where x equals 0. So here's what I mean. If we know the x and y intercept of a line, then we can graph that line, and we can discover things about what's true about those intercepts. So if we know that the x-intercept is 5, that means that this line crosses the x-axis at 5. So here we have 1, 2, 3, 4, 5. We know this point right here, because of this information right here, is where this line crosses the x-axis. Now, interestingly enough, that point has coordinates. And the coordinates of that point are 1, 2, 3, 4, 5, because it's 5 away from the origin to the right. But then in order to get the y value, we have to notice that this point doesn't go anywhere up or down on the y-axis, and so the y value of this point is 0, and that's where I get this idea. Every time you have an x-intercept, y equals 0. Every time you have a point that's on the x-axis, y equals 0. So we'll hold on to that idea for just a second. Now, the y-intercept equaling 6 means that the line also crosses the y-intercept, and it crosses at y is equal to 6. So we can count 1, 2, 3, 4, 5, 6 up from the origin, and this is our y-intercept. Now, this point has coordinates as well. Notice that this point doesn't go anywhere left or right on the x-axis, and so the x value is 0. And the y value is 1, 2, 3, 4, 5, 6. So you see what I mean? Whenever you have a y-intercept, that's where the line crosses the y-axis, but not only that, that point will have an x value of 0 every single time. So we can use this knowledge and put it together. We can take the idea that we know about the standard form of a line, and we can use the idea of intercepts and be really clever when we're trying to graph a line. And that's what today is all about. We can take this idea of intercepts and combine it with the idea of standard form and graph a line. Because as I just talked about, the y-intercept is where x equals 0, and the x-intercept is where y equals 0, and this is going to be true every single time. So here's the idea. I'll talk about it first, and then I'll show you in an example. To graph an equation in standard form, so it looks like this, first, to find the x-intercept, let y equal 0 and solve for x. And then you will also, to find the y-intercept, now let x equal 0 and solve for y. This is how we're going to do this every single time. So I'm going to actually grab these instructions. Oops, I just shocked myself. I'm going to grab these instructions, and I'm going to bring them to the next page so we can actually do it. So here's the kind of question you'll be asked. Use intercepts to graph the equation. Now notice that this equation is in standard form. Now when we're using a standard form, this technique that I'm about to show you is really, really clever. So we'll start the first part. We're going to find the x-intercept. Let's do that first. So what we're going to do is let y equal 0, and then we will solve for x. So we're looking for the x-intercept. Because if we know the x-intercept, we can put that point on the graph, and then we can connect it to the y-intercept in just a bit. So the equation is 3x plus 4y equals 12. Now what we have to do is let y equal 0 because we know there's a point on this line where y is 0. In fact, we know it's the x-intercept. And so let's let y equal 0. That would bring our equation to 3x plus 4 times 0 equals 12. Do you see how I just took this y and I changed it to a 0? Because I'm letting y equal 0. So now what we end up with is 3x, and then what is 4 times 0? It's 0, and so this whole term goes away, equals 12. See that? Because we put that 0 in for y, it made all that go away. 4 times 0 is 0, and so that part just goes away. And then the last thing to do is to solve for x, and so we're going to divide both sides by 3 to create this cancellation, and x equals 12 divided by 3, or 4. So what we know is that when y is 0, x is 4. So we have the point 4, 0. That is our x-intercept. 1, 2, 3, 4, 0, right there. Let's do this for the next one. We'll find the y-intercept. In order to do that, we have to let x equal 0. So here we've got our equation. Oh, well, let's write this down. Y-intercept. We're letting x equals 0 this time. So we have our equation, 3x plus 4y equals 12. But now we're going to let x equal 0. So we have 3 times 0 plus 4y equals 12. Well, 3 times 0 is 0, so that goes away. And we have 4y equals 12. Now we're going to solve for y. So divide by 4, creating this cancellation, and y equals 12 divided by 4, or 3. So when x is 0, y is 3, and we have the point 0, x is 0, y is 3, and that is our y-intercept. So we can plot that on the graph. 0, because it doesn't go anywhere left or right, but it goes up 3. 1, 2, 3, and there you go. And now you can connect these with a line. And that is done. So when you have an equation in standard form, you can use the idea of finding intercepts by dropping a 0 in for x and then solving for y, and then dropping a 0 in for y and solving for x, finding those intercepts, and then graphing them. It's a pretty clever little technique, if you ask me. Let's do a few more so you can see how this works the same way every time. So this is an equation in standard form, 2x minus y equals 4. This is an equation in standard form. And in order to graph equations in standard form, we can be clever and use the idea of intercepts. We're going to find the x-intercept. And the y-intercept. By using the idea that when the line crosses the x-axis, y equals 0, and when the line crosses the y-axis, x equals 0. We know that these things will always be true, and so we can jam these values into that equation and find the points that represent the intercepts. So if our equation is 2x minus y equals 4, and we want to find the x-intercept, we just need to take a 0 and put it in for y. So we have 2x minus 0 equals 4. There's no number in front of y, so it's just 0, and that goes away, because zeros always drop out of equations. And then we have 2x equals 4, and then dividing by 2 on both sides gives us that x equals 4 divided by 2, or 2. And so when y is 0, x is 2, and we can write our point. X is 2, y is 0, and the point 2, 0 goes on our graph right here. All right, we're halfway done. Now to find the y-intercept, we got to use the same equation, but we'll put 0 in for x this time. So we have 2x minus y equals 4 is our equation, but now the 0 is going to go in for x, and we have 2 times 0 minus y equals 4. Well, this goes away, boom, and we have minus y, that negative sign didn't go anywhere, equals 4. Well, remember how I told you that like having no number in front of a variable is sort of like having a 1? So we can divide both sides by -1, and these negative ones cancel, and I have y equals 4 divided by -1, or -4. So when x is 0, y is -4. When x is 0, y is -4. And that point goes on our graph. 0, -1, 2, 3, 4, right here. And then we connect them. And there's your line. Completely done. When you have an equation in standard form, you drop values in for x and y. We drop 0 in for x and y. Solve, plot, connect. That's how we do it. Let's do another one. So we're going to use intercepts to graph this equation. The equation is in standard form, and so we're going to find the x-intercept and the y-intercept. At the x-intercept, y equals 0, and at the y-intercept, x equals 0. And now we can do this. So we know the equation is x plus 3y equals -9. We're going to put y as 0. So x plus 3 times 0 equals -9. Well, this 3 times 0 goes away, and all we have left is x equals -9, nothing else to do, because there's no number in front of x, so we're done. So we know when x is -9, y is 0. Or I should say it the other way. When y is 0, x is -9. When y is 0, x is -9. And there's a point for our graph. So we go out to the left 9 places, -1, 2, 3, 4, 5, 6, 7, 8, 9, and we don't go anywhere up or down because that's what that 0 means, but we also know that that's where that crosses the x-axis, and so it's going to be right there on that x-axis. So there, we're halfway done. Let's do it again for the y-intercept. We have x plus 3y equals -9. Now we're going to take that 0 and put it in for x. So we have 0 plus 3y equals -9. Well, this 0 goes away, and we have 3y equals -9. Divide both sides by 3, and y equals -9 divided by 3, or -3. And so when x is 0, y is -3. And we have the point, x is 0, y is -3. Done. So we'll put that on our graph. 0, -1, 2, 3, right here. And now all we have to do is connect them. Oh, I did a terrible job. Let me erase that. There we go. I'll try this again. I really should use a ruler. Well, that's not bad. Okay, there we go. Done. That's it. So the whole idea here is just to be clever, to recognize that if you have an equation in standard form, we can plop zeros into that standard form, get rid of a whole term, solve for a variable, and then plot that as a point. In other words, we can use intercepts. We know at intercepts that one value or the other is always going to be 0, and that helps us graph these lines. All right, I hope that you know how to use intercepts to graph equations in standard form now, but if you don't, you could come to office hours and you could ask me. All right, you guys, I hope you have a wonderful day. Bye.